Now let's see what are the service interface function blocks. So service interface function blocks, these are mechanisms for interacting with different hardware resources. It can be, as analogy, we can take providers of printers. Each of suppliers of printers supplies them with drivers. And these drivers can be used in any personal computer to interact with these printers. It is very similar with service interface function blocks. So these function blocks are supposed to implement the device hardware dependent functions, so helping the application program to interact with the services of devices and masking them and making them standardized. For example, there could be access to outputs and inputs of a particular PLC, or it could be access to a timer function of that PLC, or reading system time, or accessing communication interfaces of the PLC. So application developer is not expected to develop such function blocks. So these function blocks are supplied by device vendors, and in most cases application developers just take them from libraries provided by device vendors, drop them into their application programs and use. However, in some cases, in this instrument of service interface function block can be actually used for also encapsulating and protecting intellectual property. When you want to create code and supply it as a black box to your customer, you can also develop it in the form of a service interface function block. In any case, the user of service interface function block in most cases does not see the implementation, the code that implements this functionality. That is why standard developers have provided the mechanism to document this functionality in the form of service primitives in the sequence diagrams as it is shown in this picture. So in the sequence diagram we have two sides. One is application side and another is resource side. And using the arrows, we show the sequence in which events occur at the input of a function block and what happens afterwards. So like for example here, the initiator and responder, the pair of two function blocks that implement some interaction. So first we send init event to the initiator input, and after some time at the resource side the service is started. After service is completed, the initiator is informed by init O event. And so that's the initialization part of the functionality. And then there's a main part of the functionality when the function block is activated by the rec event, and it writes outputs. And also if the inputs arrive from the resource side, the input are provided as a RD and from 1 to n outputs of this function block. So this is a language that is not programming language, but it's rather documentation language describing the behavior of the function block without showing to the end user any details of its implementation in code. So there are several libraries of function blocks already defined in IEC 61499 standard, and one of these is operations with events. So there are several standard events operations implemented as function blocks, and these are listed in this picture. So there are events splitting, merging, and rendezvous of events. There is a permissive event propagation function block. There is selection of one of two Boolean inputs with an event, so selection of two events with a Boolean flag. There is a switch, event demultiplexer. There is a eDelay, event-driven timer delay. There is a block for periodic event generation called eCycle. The block eRestart implements interface to a resource that can indicate to the application that it's restarted in a cold or warm way, or it has been stopped. And there are also blocks for generating finite train of events, create event-driven trigger service interface function block. We can present function blocks that provide access to output variables and input variables of a PLC, to input and output modules. So these can be represented as function blocks. Of course, any application program needs to interact with these event and output signal ports, and in the program they can be represented as a standard service interface function block, which you just drop into your program. Then you parameterize them, telling which port you will interact with, and then you just, to write data to the output port, you just make them available. You send them to the corresponding function block, service interface block, as it's shown here. Or if you want to receive data from the input ports, there is a function block for that, and whenever data is changing at the input port, the corresponding event can be generated and can activate your application controller function block. Another particular case of a service interface function block are communication interface function blocks. So the standard arrives two modes of communication. One is publish subscribe, and another is client server. Publish subscribe is a one-to-many communication model when a message is sent across some network stack protocol to many subscribers in kind of multicast way. And another is point-to-point model where client and server, so they are connected in a point-to-point way, and they can transmit data to each other in both directions. So as it is shown in the right-hand side of the slide, for example, for the publisher-subscriber case. So first, publisher is initialized, then independently subscriber is initialized, and this is a prerequisite for data transfer. So first the blocks need to be initialized, but if they are initialized, and then a rec input with the data associated with that rec input occurs, and the event will be, along with the data, will be forming the package, the message, and the message will be sent across to the subscriber side. On the subscriber side, the IND function, the IND event will appear at the output here, and the data will be converted into outputs of the subscriber function block, RND, from RND1 to RDM. So the application may want to send some confirmation of sending, but there is as you can see, there is no connection between these two things. So the response will be just confirming to the subscriber block that the data is received by the application, receiving application side, while upon the sending, the publisher block will inform the sending side of the application by the CNF event.